On the 29th of April 2016, the H225 LNOJF helicopter operated by CHC Helicopter suffered a fatal accident near Troy in Norway. Each and every one of us was deeply affected. Understanding what happened that tragic day has been a #1 priority for Airbus helicopters ever since. We have made all our human and material resources available to investigators to enable them to complete their work as quickly as possible. Initial observations revealed that the rotor had separated from the cabin. In response, we began by listing all the possible scenarios that could have led to such an outcome, even the most improbable ones. One by one, every branch on the fault tree analysis was put to the test in order to confirm or rule out each hypothesis. We drew on all the information gathered by the investigators on site to piece together exactly what happened. Each and every detail was taken into consideration. We also used complex numerical models in simulating different failure modes, comparing them with observations of the actual parts. In the meantime, we considered and examined a 2009 Super Puma accident that bore similarities. Finally, we carried out about 2,000 hours of testing in dozens of different tests, the aim being to reproduce the failure scenarios envisioned and to identify which one actually occurred. In total, more than 370 people were called upon during the course of a year. Throughout the official investigation led by the Norwegian Accident Investigation Board and supported by Airbus helicopters, we were able to identify precisely the sequence of events. The origin was traced back to the inside of the main gearbox, a key mechanism in the aircraft, as it transmits power from the engines to the rotors, while reducing rotational speed from 23,000 RPM to 265 RPM for the main rotor. The inside is a series of reduction stages comprising gears manufactured using the finest material and surface treatment technologies and in line with the highest quality standards. The second stage epicyclic gear train comprises a sun gear, 8 planet gears, a planet carrier, and a fixed ring. Each planet gear contains 2 inner races, 2 rows of rollers, 1 outer ring. It is inside this ring that the failure began, with an initial and very limited spalling. Unexpectedly, this very limited spalling gave way to a crack, which then spread until the planet gear split in two between 2 teeth. The space between these 2 teeth grew, causing a collision with a tooth on the sun gear. The planet gear broke instantly. Pulled by its own inertia, the main rotor caused the top section of the main gearbox to shear off and separate from the structure. Let's go back to the beginning, however. How could such an accident have happened? The potential contributing factors were identified, and safety barriers were put in place to eliminate their reoccurrence. One of them is the non-detection of very limited spalling. Spalling is a normal degradation of bearings that remains acceptable up to a certain amount. This is monitored with magnetic plugs that collect the metallic particles. In the case of LNOJF, the defined practice of particle detection was not sufficient to reveal very limited spalling. We have therefore improved this practice of metal particle detection. The frequency of inspections has been significantly increased. Stricter removal criteria have been put in place regarding particle sizes. Detection methods were completely overhauled and now include a latest generation magnetic plug with increased performance. Another potential contributing factor is the phenomenon of fatigue. Some metal parts subjected to high repeated stress have a defined number of cycles before their possible failure. Airbus helicopters therefore defines a maximum operating time for each part. In 2004, Airbus helicopters defined a maximum operating time in accordance with the certification requirements. In 2017, based on the learnings from the accident investigation, this maximum operating time has been reduced by a factor of 4. Another potential contributing factor is linked to the design of the planet gear. 2 suppliers manufacture these planet gears, and their designs are not 100% identical, even if both match the technical specifications. The second creates greater contact pressure and was used in the LNOJF's main gearbox. This planet gear has now been prohibited outright. The only planet gear now present in our Super Puma family has registered 22 million flight hours without any outer race spoiling having been detected in normal conditions. Another potential contributing factor is external damage occurring to the main gearbox. Before being fitted onto the helicopter, the main gearbox in question sustained a fall during a road transportation accident. It has been decided to withdraw from service any main gearbox having suffered a shock, a lightning strike, a hard landing. In addition, we put in place a series of initiatives to improve the shock resistance of the main gearbox during transportation and to better report back any unexpected event. Sensors that capture parameters such as temperature, pressure, altitude, lighting, inclination, and shock level have been placed on the main gearbox, and previous history of the part can be closely monitored. The packaging for the main gearbox now includes highly visible stickers that change color if the crate sustains a certain level of force or shock. The last potential contributing factor is a contamination by impurities finding their way into the main gearbox during maintenance, which then could have created damage in the planet gear leading to spoiling. Additional measures have been put in place to protect the main gearbox during maintenance operations, and disassembly of main gearbox modules can now only be performed by an Airbus helicopter's certified maintenance or repair centre. The safety barriers put in place are aimed at eliminating the contributing factors to the LNOJF accident. Based on these measures, the European Aviation Safety Agency and all aviation authorities worldwide have approved the return to service of the H225 and the AS332L2. Any accident is one too many, and in order to reach our zero accident goal, we are committed to continually improving. The investigation underway led us to thoroughly review and rethink many of our quality and safety processes, not only for the Super Puma, but for all helicopters in the Airbus range. One example is how we are working on improvements for handling and tracking dynamic components. This includes developing better solutions for documentation, repair feedback, and digital solutions for better traceability. Furthermore, taking what we have learned from these investigations, we have gone back and checked the stress analysis for all our aircraft. We took additional steps and applied the same strict standards on planet gear bearing contact pressure to our other helicopters, which led to the removal of 2 types of planet gear as a precautionary measure for the Dauphin family. Finally, we have launched a research program to innovate how we analyze vibrations. The vibration detection systems on the H225 are used to collect and analyze critical data to optimize the helicopter's availability and safety. We are working in partnership with leading university research centers on the detection of occurrences such as spoiling and cracks. We already use vibration as a way to detect damage in fixed gears, but applying these methods to moving gears, such as epicyclic gear trains, does not exist. It requires the use of new sensing technologies and complex signal processing methods. We are seeing some promising developments in this field. All this leads to improve our safety culture. To you who fly in our helicopters every day to complete your missions, and to you, our employees who test each helicopter before it's delivered, your lives are invaluable. We are doing every day everything in our power to learn from this experience and to ensure that the Super Puma is flying with an increased level of safety. Just as we rely on your continued faith, you can rely on our unbending commitment to safety.